Hello and welcome to today's CIBSE webinar. A few sort of housekeeping notes just before I hand over to today's speakers to introduce the webinar. Today's session will be recorded and a link to the recording will be sent out tomorrow. If you're having any difficulty hearing or seeing our speakers today, we suggest that you log out and log back in, and it tends to work best using Chrome. There is a chat function, so please do post any questions that you have for the speakers, and we'll aim to address those after today's presentations. So I think that's all from housekeeping, but so I'll hand over to Amy to Julie to introduce today's session. Thank you.
Hello everyone, can you all hear me? Can someone? Yeah, great. So I'm Julie Godefroy, Head of Sustainability at CIBSE. Thank you very much for joining today. We're really excited to start the series that this committee put together. And I think it's a very exciting way to launch a committee. It's a bit better than just a launch event. So all I want to do is speak very briefly to put the work of this committee in the context of what CIBSE is doing on climate action. So I'll try to share my slides now. Have I disappeared? No? Can you see my slides? Yeah, yep. I'll assume yes. So hopefully you already know that CIBSE has a climate action plan. We've had that for 3 years now. It was first published in 2019 and we update it every year. It covers everything that we think we can or should be doing as an institution. So not only the technical guidance, which is probably the part that you're most familiar with, but also things like education, training, how we keep driving standards through our awards, for example, what we do as an organization in our own offices and activities, etc. So this is the page where you can find the plan, and it then takes you to all sorts of other links, but specifically on guidance. The work of this committee fits quite well in lots of activities we have essentially around climate adaptation and net zero. The first part of our work is, I would say, on strategic aspects. So first of all, what do we mean by net zero? Hopefully most of you have seen in the past year or so all the work we've done, because we had quite a lot of member engagement, surveys, etc. We adopted the whole life carbon network definitions of net zero. We published with Letty on net zero FAQs this spring. And recently we've started as a cross-industry group with the RBA, Astracti, Letty, RICS, etc., the net zero carbon building standard. I'm sure many of you are involved because we had thousands of applications. So that's a key part of our defining net zero work stream. We also, again, hopefully, as all of you know, have energy benchmarks, which are online and have been online for many years. Do have a look because they are regularly updated and grown. So for example, last year we launched the first benchmarks for homes, which at least CIBSE had never had. And there will be additional functionality added in the future. More specifically, on more detailed guidance, we have, say, core 4 work streams. One is on embodied carbon, first with the methodology for building services published a couple of years ago, and we now have follow-up publications on systems, applying TM65 in other countries, potentially creating databases of products, etc. We have lots of work streams on heat decarbonization, especially heat pump, but also related aspects, so hot water temperatures, heat networks, etc. Electrification of buildings for net zero. We have a dedicated working group and we published the first piece of guidance late last year. And finally, retrofit. We engaged with the Letty domestic retrofit emergency guide published last year. We now have a joint working group to produce the equivalent guidance in the non-domestic sector. And finally, this very new committee specifically on interventions in retrofit in heritage properties. I'm really happy about this because we've had a heritage group for many years, but it tended to focus on historic building services, while a lot of us just want to know what to do with all these beautiful buildings. So that's it. The last thing I want to leave you with is where you can find all our guidance. We have a page. I know it can be difficult to navigate our website. Hopefully it's easier with a new website, but we do have a page specifically where you can find all our guidance on net zero. Thank you very much.
Thanks, Julie. Thank you for the introduction there to the committee. As Julie mentioned, we're a newly formed committee focusing on knowledge share in the realm of retrofit and heritage buildings. Caroline Catini, who is the principal team leader at Historic England, and myself, Amy Punter, Associate Director of Hawley, we are co-chairing this newly formed committee. And so I will pass you over to our first speaker, Oliver Smith, Founding Director of Fifth Studio. He's going to provide some insight into the deep retrofit of the Grade 1 listed new court at Trinity College, Cambridge.
Thanks very much. Thanks for inviting me. Can you see that?
Mm-hmm.
Good. I'm going to talk about a project in a new court in Trinity College. It was built by William Wilkins in 1825 on a shoestring budget. This is the first picture of it we found, 1865. It's kind of Roman rendered courtyard elevations and a stone elevation to the river, which is this one. And the college wanted to provide sustainable student accommodation. This is a map of their estate, and everything in pale blue is Grade 1 listed. And the opportunities for them to do anything that didn't involve tackling a Grade 1 listed building were extremely limited. So we, over a process of 3 years, we worked with college, Historic England, and the local conservation officers to work out how you do this, what might be an appropriate methodology, and how you evaluate the existing building in terms of retrofit options, and how you optimize the kind of solutions. So I'm going to talk about, very briefly, just give you an overview of what the project was about. So we wanted to provide 21st century rooms within the historic interiors, and 21st century in terms of expectations of character and comfort. We wanted to renew the fabric of the building, particularly of the facades, because over the previous 180 years, hadn't been a lot of care applied to those. But principally, the college wanted to explore the potential for sustainability of the fabric and the systems, from a kind of fabric first approach to demand reduction, to improving the efficiency of the services in the building, and ultimately to providing renewable energy sources. And the kind of rule we started off with, target we set ourselves, was to taking the existing carbon emissions to halve the demand through fabric improvement, double the efficiency of the system, and then halve the carbon in the supply of energy to those systems. So that got us to about an eighth, which in 2010 actually was the kind of target that we were asked to aim for. And the strategy was, as in terms of kind of design and interventions in fabric, was to insulate the fabric, double glaze or triple glaze windows if we could, make the building airtight, but introduce mechanical ventilation with heat recovery using the chimneys as the supply ducts to every room. And at that point, having reduced the heat loss to a point that we could heat the rooms with underfloor heating laid under the existing historic floorboards, and then provide heat to those from a ground source heat pump and borehole array. That's the bit that hasn't been done, and the college are going to undertake that fairly shortly. But by the time we'd finished, they were sort of suffering from disruption fatigue. So that's yet to be done. This is a snapshot of an interior. This is a Grade 1 listed interior. There is slimline double glazing in the windows, which have been repaired and upgraded to take draft and weather strips. We've repurposed the shutters, opened all those up so that we haven't got curtains and blinds and kind of tut. There's an insulated lining to the wall which stops short at the cornice, so you can read the original footprint of the room, the original boundary, the original enclosure of the room, and then all of the services and all of the behavioural interfaces happen within this fitted furniture, this kind of timber furniture, and then the floors have been relayed, I say, over the underfloor heating. What we actually achieved was a 60% reduction in demand. We didn't quite manage to double the system efficiency, and I say in 2022 we're at something like 20%. The college have reported that the energy demand and carbon emissions have been reduced by 80%. So when we get those boreholes in, things will improve even more. In terms of other outcomes, the rooms are really popular. The students are saying, yeah, 80% of them would recommend those rooms to other students, and it's the nicest place to live in college. In terms of performance, we didn't, a slight digression on badges perhaps, we didn't go for Passive House or Benefit badge because we wanted to really evaluate how the existing building operated before we adopted targets for it. And the targets for each of those elements, walls, windows, whatever, were determined by what was appropriate to achieve in the context of the listed status of the building and the retention of as much historic fabric as was possible. So although we didn't meet the kind of elemental requirements for quite a lot of the NFIT targets, in terms of outcome and kilowatt hours per metre squared per year, we're just below the NFIT Table 3 target. So I think badges can be quite a dangerous thing to adopt if you're retrofitting heritage. They set targets for things which really need to be explored on an individual basis. And actually, we're finding that increasingly the targets that clients want to set are those established through SALEX, the Public Sector Decarbonisation Scheme, and that there you're talking about pounds per tonne of carbon saved over a lifetime, which actually works pretty well for things with a very long lifetime, like insulation. Anyway, enough of that digression. I wanted to really talk about the work we did before we started building, looking at how the risks and unintended consequences arising from retrofit in terms of occupant health, fabric health, and character and heritage significance. And these are completely inseparable. I mean, it's really difficult to address one without addressing the others, but it really helps if you know where you're starting from. On terms of human health, the relationship of respiratory disease and the installation of central heating is pretty well established linkage, but we're now finding that in really airtight buildings, UCL have published this, we're actually getting tuberculosis transmission, and a lot of buildings with new ventilation systems that haven't been properly designed, installed or maintained are actually pretty unhealthy buildings. There's a report on them, on the effectiveness of ventilation in new build London homes. It's pretty scary. Not going to go into that too much because that's a whole other topic. In terms of the risk to historic fabric, we undertook kind of 5 basic levels of monitoring of the existing fabric before we even started. So we did interstitial hydrothermal gradient monitoring so we could see how the historic fabric worked in terms of vapor movement, moisture movement, and air movement. We did pretty critically in situ U value measurement, and then thermal imaging with a blower fan in tandem. I mean, the blower fan was actually sucking air out of the building, and we went around the interior and were able to work out where we had uncontrolled ventilation. And then we monitored the thermal and moisture inputs to the fabric in the rooms themselves and in the spaces between the rooms. So what happened when all the students came back, what happened when the heating went on, what happened when the students went away in the depths of winter, all that stuff. We needed to understand how that all worked. In terms of air tightness, we arrived at a figure of about 11 cubic meters per meter square at 50 pascals, and we were aiming at 3. So that's a lot better than the building regs, but short of Passive House. I mean, you can see radiators through brick walls, such was the kind of nature of the performance. But this is fairly standard thermal imaging kind of outcomes for an unimproved building. I think the critical one, the critical lesson that I learned through this was that if you do a standard U-value calculation for these walls, you come up with a U-value of somewhere 0.95, nearly 1. If you actually measure it, you're closer to 0.7, and in some cases 0.6. So that's a 25% difference between the measured and the calculated U-values. And given the sensitivity of historic fabric to being internally insulated, which in this project was the only option we had, that's a big difference. And it gets, you're a lot closer to your target than you would have imagined you were if you'd simply done a desktop exercise. And you'd have put too much insulation in and incurred too much risk, I think. The hydrothermal gradient monitoring just showed us whether we had existing dew points within the fabric, and that enabled us to, that formed the basis of some of the WUFI modeling we did later on. I'll come on to that if we have time. Materials property testing, quite intrusive, but gave us useful samples of core samples that we could actually send off for analysis in terms of the exact material properties. And the input from the moisture and thermal monitoring actually didn't reveal anything that we couldn't have imagined, but we had no way of knowing that before we did the monitoring. In terms of the other risks, like architectural character and heritage, obviously we did all of the stuff you do in terms of looking at the fabric and the particularities of the fabric. This building had been over-rendered with the Portland cement render in the 70s, and they had tried to match the color of the exposed Roman render, ignoring the fact that originally it had an overwash of a lime wash of something much warmer in color. So we were kind of looking to rectify that. And we did lots of stuff that you're just expected to do by historic England about features and fabric, particularities of fabric, but also categorizing how many really special rooms there are and how many actually, the very largest part, are pretty bog standard rooms that have been destroyed by iterative interventions. And what we came to was the realization that the most important of the heritage significances of this building was the robust way it adapted itself to use by each successive generation of students. So in the summer, the building would be kind of cleaned out of all of the soot of inhabitation and then occupied again. And in a way, its resilience to that kind of annual reoccupation and kind of inhabitation by a new generation of students was the most critical aspect of its heritage significance. Quickly, these are two photographs of finished interiors, overdrawn on the left with the monitoring stuff that we built in to check that what we were doing was what we'd modeled would happen, and on the right showing the way that the service installations were incorporated within the interiors. And I'm going to talk a bit about models. We used WUFI modeling produced by the Fraunhofer Institute. I found at the top of this slide, I found the outputs more or less completely unintelligible. What did it mean? What did it tell you about risk? What did it, they were just numbers. So we decided to output the WUFI model against the isopleths for mold growth, because that was the risk we were really talking about. We were worried about joist ends in the wall, timber wall plates, a little bit of softwood grounds that skirtings were fixed to. Those were the things that would rot if we were creating dangerous conditions within the wall. So we plotted the outcomes from the WUFI model against those isopleths, and you can see that had we used 150 mil phenolic foam and a vapor barrier, we'd have been knee deep in dry rot already, possibly. 100 mil of wood fiber didn't really create ideal conditions for mold growth, but were still too risky, and we ended up using 65 mil, which was then clear of these lines as kind of sensitivity. We built a test wall, and we monitored the conditions in that just to make sure we didn't actually get a dew point within the construction, and we monitored that for a year. So, I mean, it's pretty, the brief from the college was, we have the budget and this is an ideal building. We should do all this work and we should disseminate it so that other people don't necessarily have to do it. And this information is all available, publicly available through the planning portal. This is a picture of the test wall. On the right is the insulated panel. On the left is the uninsulated panel. But other kinds of modelling we did, addressing the issue of character, or what does it mean to a classic listed interior if you put an insulated lining in, how does that relate to the scale of furniture? This is a 1:10 model. We actually built a full-size mock-up room, but we certainly built an awful lot of full-size maquettes of details for discussing with Historic England officers and with conservation officers to arrive at this idea that you left the cornice where it was. There were obviously concerns that it formed a cold bridge. It proves from monitoring it doesn't form a cold bridge, it forms a cool bridge, but not cool enough to have condensation form on it. And then I'm going to quickly talk about optimize. Well, we need to optimize the designs for retrofit of heritage to adapt to the limitations of the UK construction industry. They like this kind of thing, driving around a historic interior in a digger. We need them to do an awful lot more of this kind of thing, which is really carefully reglazing with slimline double glazing and a rolled glass exterior sheet, carefully reglazing, you know, historic timber joinery and whatever. We don't train our UK construction industry professionals to work with listed buildings and the kind of materials you need to work with listed buildings. Lime render was complete news to them. The idea that you have a limited season in which you can use it, that either it's really critical how thick a coat you apply and so on. It might be part of the conservation contract as well, but if you're talking about a project with 200 rooms, then actually those guys don't qualify. So our mainstream contractors are not training their workforce with the requisite skills, and it required a huge amount of site supervision by ourselves and by the contractors. We ended up with a team that was 30% supervisors, which was way beyond anyone's expectations, and we had a full-time presence on site. And then finally, one of the things one hears from clients with historic buildings is, it's okay, the grid's decarbonising, we'll just shove in air source heat pumps to replace our boilers and it'll all be all right. Well, we did some analysis of, I mean, and they're right to an extent. The electricity, the carbon content of the electricity now is about a quarter of what we had at the beginning of this project. But the future energy scenarios published by the National Grid suggest that we're going to have, and Newcourt would fit within this category, supply capacity for residential buildings of about 60 kilowatt hours per meter squared per year. And this year's figures suggest it's even going to be lower. So that imposes a supply side imperative for retrofitting existing buildings and historic buildings to the kind of standard of Newcourt. I think we learned a lot of lessons and there are quite a few things we wouldn't do and we're not doing on subsequent projects. But the supply side imperative is something that's not talked about very much. And I think that needs to be part of the equation when you're evaluating a heritage retrofit project. I've probably overrun, so I'm probably going to stop. Yeah, that's my last slide.
Thank you very much, Oliver. That was fascinating. And to be honest, I think the first talk straight off has proven to me why Carol and I wanted to start this committee, to share knowledge on projects exactly like that. It demonstrates immediately the power and the reason for doing surveys, to demonstrate that you don't want to just rely on calculated U values, for example, what you tabled there in terms of what's achievable in the results. Through putting the effort into the surveys and demonstrating actual performance and then refining how to improve things, it's just so powerful, and also further supports the case that you can make a real difference in the retrofit of these historic buildings. I think a lot of people shy away from them because they're seen as too difficult, but you know, there's real value in doing this in the route, well, the race to net zero. So that's enough from me on that point. I just wanted to say thank you for that. It was so interesting. And if anyone's got any questions as we go, please do add them to the chat. And Caroline will be chairing the Q&A session at the end of this. And then I'll pass you over to John Perrowet. He is one of the associate directors at Hawley in the performance group, and he's going to be discussing performance, evaluating and optimizing building performance. Thanks, John.
Hi everyone, thank you Amy, and thank you Oliver for your presentation. Hopefully you can all see my screen now and see my slides. Thank you. So really what Oliver's presentation touched on, I think, was how much is possible when really going into every elemental detail, and particularly in terms of one holistic project, being able to go fabric first and lead on from there. What we do in the performance group at Hawley is working with operational buildings more, so going in and looking at how we can reduce their energy consumption with the systems they currently have, where we might then look at replacing certain kit and then taking that further and further towards net zero targets. So in terms of what the presentation is going to cover here is initially really just looking at with clients, what does better mean for them if they come to us saying they want to optimize their building? What are their criteria for that? Then looking into the wider industry targets, looking at net zero carbon and what the targets should be and how we define those, setting the targets for the building. And once we have our targets, looking at what our baseline consumption is, where can we go from there? Then tailoring this more into, well, heritage buildings. Prior to this in the presentation, I've gone through the general process, but in terms of heritage, what are the limitations? What are the considerations there that might mean we do things a little bit differently? And then finally into how we would approach optimization on such projects. So in terms of building performance of what the metrics are, particularly for the client, what we really aim to do first off is spend that time with the client understanding what would be their measure of success in the project really. What are they judging themselves on? You know, when we're talking about optimization, it's often looking at energy consumption, carbon emissions, etc. But for education establishments, it might be more about the grades of students or the number of papers published. It can be productivity, so we're getting into air quality when looking at workplaces. So again, it's very sector specific and really understanding from the client, what are they really looking for? So that then brings us into the wider industry perspective and how we would look at targeting net zero carbon on existing buildings. So we're following the 5-step process set out by the UK GBC. And really what we're talking about today, the first 2 steps there, we've got the assess, which is the evaluation of where we are now, and looking at the reduction, which is the optimization and beyond. Now it's really that second step where the input to all of these steps isn't necessarily equal. The effort, the time, the thought processes to go into the reduction stage shouldn't be underestimated. There's so much that can be done at this stage that really sets the platform for the remaining stages. So everything you can do to reduce your demand in terms of electrical and your heat demand impacts how much you're looking to generate on site, how much you're looking to source from off-site. So really we start with finding out these 2 things. How much do we need to try reducing by? And then what do we look to reduce? So in terms of how much to reduce, we've got the industry energy targets that many people are familiar with now from UK GBC, LETI and the like. These are largely sector specific at the moment and give us certainly the targets for the Paris Proof 2050 timing. With regards to offices, that's been broken down into intermediate targets, and we expect similar will come out of the Net Zero Carbon Task Force in terms of other sectors and refining some of those targets. But typically, the target levels in 2050, you're often around about 60% below existing consumption levels, and that helps to inform, if we're looking at a more bespoke building, what's a reasonable target to start looking at. So really we take the ultimate target, then break that down into 5-year targets, and by applying percentages to this, you can see that typically you're expecting to get some of the easier wins in the early years, and then you're really starting to push the limits of what's possible as you get towards that target point. So really on the evaluation point, once we have our targets, we need to see, well, where do we sit against those targets? So there's a fairly simple starting point of just looking at the building's energy consumption for the previous year, and kilowatt hours per metre squared is the typical measure, and really that gives you this section of this diagram over on the left. It's your whole building consumption. But if that's a lot higher than your target level, which it probably is going to be, you need to start delving deeper into where all of that energy is being used. So in the instance of this diagram here, which was an office, we had great granularity on tenant usage. But then when you come to the central systems, which we would probably have more control over, there's not really the granularity there, only in terms of knowing, well, how much of this is electric, how much is gas. Typically what we would be looking for in order to optimize and understand where the biggest opportunities are to understand how much each of these systems listed down on the left is. So domestic hot water is often overlooked, but really refining that helps us also to split out what's used for hot water and what's used for heating then. Catering can be a large energy use, cooling, ventilation, lighting and IT, all significant uses that we want to quantify early on. So just as an example for going into a project where we want to look for that granularity, this being a typical kind of gas-fed boiler system, or it could be heat pumps, where you've got low temperature hot water feeding off to a heating circuit on the bottom there, and domestic hot water generation on the top. So quite often, particularly in some of the older schemes, you would only have a figure for consumption of the whole system. It might be a heat meter on the output from your generating plant, or it might be your gas meter on the input to the boilers. And this is where in the evaluation stage, we would look to either apply further metering, or as that can be quite disruptive, particularly in heritage buildings, even just clamp on temperature sensors on the pipework can give a much better granularity on where the heat's being used and when. So typically, if you've got the overall system consumption, you would want to measure your heating system's consumption. And rather than rely on just taking the difference between the two, it would be best to then apply a meter just on the domestic hot water generation. And then the one that can often be missed out is a meter on that cold fill to the hot water, so that you can quantify exactly, we've used this much water in the hot system, this is the heat input. And from there, you can understand your circulation losses, your storage losses, and whether a different solution might be more efficient or reduce your energy consumption. The other side of the analysis at this point is the massive benefit of half-hourly data, if we can get hold of it. Now, it is typically quite readily available now, particularly for utility gas and electrical supplies. So particularly if you've got a gas-fired heating system or heating and hot water, if you can get the data from the utility supplier, you can quite quickly come to a conclusion about how the building is using the heat available to it, how often did it see the peak loads. And this kind of analysis really informs some of the decisions later on about main plant sizes, maybe sizing modular plant. So in this particular example, we had a scheme with gas boilers of 1,750 kilowatts installed. From the data, we could see that the peak output for the system was only ever up to 770 kilowatts, so significantly less than the installed already. And actually, when you look at it, for 98% of the time, you're looking for heat at 450 kilowatts or less for the building. So that can help inform replacement plant sizing, particularly important now when we're talking about heat pumps on buildings and electrical supplies, space for the air to flow around the heat pumps, etc. And really, by taking this approach, you can reduce the space requirements to something that's much more manageable instead of going for a simple like-for-like replacement, and the electrical loads become much more manageable. And these both points very key on particularly the heritage buildings, because your space restrictions for heat pumps and the airflow could really be a driving factor in what you're able to do with the building. So then tailoring all of this to heritage buildings, probably making a few sweeping statements here because they are all very bespoke. But in terms of our experience of what you might typically expect when looking at a heritage building, your typical baseline may well be quite low consumption compared to other sectors of buildings. There's not often that much process consumption within them. Lighting will often be quite old and may even be heritage listed. In all those instances, there should be good opportunities to install low energy replacements and still be sympathetic to any heritage requirements. And a lot of the buildings may well be natural ventilation and reduced or minimal cooling needs, really down to the way they've been built with increased thermal mass, small windows, etc. The big exception we see is libraries and museums, where conditions actually are very tightly controlled, and that's a real area for focus on optimization, whether those tight controls are working as they should be or fighting each other. Typically, you might expect gas consumption for the heating and maybe quite limited domestic hot water in the building. And then really on the right here, going alongside nicely with some of the things Oliver talked about, the typical fabric, you'll often have single pane listed windows in place, and you want to look for opportunities to replace with double glaze if possible, or consider whether secondary glazing is feasible. We've often seen a number of buildings with really high doors as well, which creates some limitations or challenges in terms of if it's a main entrance door, that's a lot of external door or external air coming into the space that then needs to be treated. And if there's anything that can be done to just make that more suitable to the use of the space, even if it's internal doors between two differently conditioned spaces, that can be energy loss as the air transfers between the two. Often you might find that heritage buildings are quite leaky in their nature, and there should be a good opportunity there for draft stripping, filling holes and making them more airtight. Walls often will find external insulation opportunities are limited, as Oliver touched on, and the internal insulation, depending on the building and the listed nature, is worth looking into the opportunity there. And roofs, typically because of the disruption, they will need replacement or upgrading at various points, and that's when it should be factored in to upgrade their thermal performance. In terms of how we would then approach a optimization and improvement project on heritage, on the elemental side, we've touched really on the heat loss reduction from the fabric and infiltration, and so seeing what's possible on the fabric side. In partnership with that, or sometimes instead of that, is looking at the scope for increasing your heat emitter sizes or types. So again, where you've got systems perhaps with smaller radiators at a high temperature gas circuit, you want to look at introducing lower temperature plants such as heat pumps and those working with larger emitters. And again, the pipe sizes and the routes actually can factor in massively on some projects and dictate the services solution, where heritage limitations on the fabric mean that you can't take certain routes or install certain types of emitters. And really then when it comes to the main plant and what we'd be looking to do in terms of a decarbonised solution, air source heat pumps would always be given consideration, and this is where we appreciate that the limitations for a heritage building can be quite restricting on this option. We've seen in those instances ground source heat pumps can be very applicable on heritage buildings, and because they have limited impact visually and on the fabric, obviously looking for the external space to put the heat rejection and gains from. In the longer term, so not necessarily as a short-term solution, but consider whether you might replace some of the existing plant with hydrogen or biogas boilers if and when the technologies become suitable. But really what we're seeing, I think, in the short to medium term is quite possibly hybrid systems. So where you might not be able to get the fabric down to the performance levels required or the emitter sizes needed to work with heat pump systems, then there are massive gains still to be taken from having even a small heat pump in that will do heating for, say, half of the year, and then have your existing or a refined gas heating design that will top up to the higher temperatures at the peak times when needed. And once you get into the hybrid systems, this is where it's also worth considering modular solutions, so that you've got plant sizes very well aligned with the loads of the building, and you're not necessarily two big boilers that are running more than necessary. And this is where the earlier diagram comes into play, because in this example where you might have considered a heat pump being ideal at 450 or 500 kilowatts output, even if you were able to get one in at up to 100 kilowatts, then you're using electricity for half of your consumption for heating through the year, and just using the gas as and when required to top up above that. So then looking into the optimization steps of what you may already have. So this is where we're considering an operational building here that's to try and do as much of the fabric work as possible might delay the project further and further. So actually looking at optimizing what you've already got in the building to take the easy wins and to act quickly. And some of that will then buy you the time to look into the fabric performance and improve that over time to get your final target levels. So what we find frequently in optimizing building systems, what we usually come across, time clocks is a fairly obvious one to check in on, and it's particularly worth revisiting in hybrid working times and similar, because that may be different. You may have far fewer people early in the morning or later in the evening, and you can tailor the operation of the systems to suit. Dehumidification controls is also one we've come across in buildings where previous guidelines would have required humidification or tight humidity control in the buildings. Subsequently, the humidifiers have probably been turned off because of the high consumption. But what still happens is the control in the air handling is we'll still do some overcooling and reheating and a loss of energy there. So it's revisiting those controls. I won't go through each of these points, but it's really just picking up on some of those key ones. The demand control ventilation as well, very prevalent in reducing operational energy these days. So you're taking the benefit of running your fans down based on understanding the CO2 and air quality levels in the spaces. Then when we move on to replacing what's inefficient, pumps and fans are often the first place to look, looking at how old those are. Lighting, as I've touched on before, there should always be some good opportunities in there. And then we've got, in terms of tempering the people and not the space, it's really looking at where the people are in the building at various times. So not heating the whole building all of the time if you know that people are going to be in one space for the morning and move into another space later on. And this is quite common in schools and education establishments. Likewise in entrance areas for schools and the like, is really just trying to heat the staff that are sat in those spaces rather than trying to heat the whole space where the external air may be coming in and replacing quite quickly. And then just in terms of reducing what you need is largely what we've talked about with in Oliver's presentation, but seeing what you can do about insulation levels, glazing, checking out risks around cold bridges so that you're not creating problems down the line, adding shading where possible, got relocating some of the internal uses. So for example, your high IT intensive areas, moving them away from any south facing facades to avoid the additional need for cooling those. Considering remote working, and also into the IT strategy of seeing where those main IT uses are now and whether they move off-site as a better solution. So that concludes my part of the presentation. Thank you very much, everyone.
Thank you, John. And another really interesting presentation there. I think it's so interesting. The more occupancy evaluation studies, post-occupancy evaluation studies undertaken, more and more reporting that the systems are just very rarely operating at the capacity that they need to. So it just proves the importance of doing these evaluations. And I particularly support the point about those easy wins in the short term for the client and occupier to see the immediate benefits. Before passing to the questions, you probably have all known that on the organisational sheet briefing for this presentation, we were going to have Andy Piper as a guest speaker as well, who was the technical director for the restoration and renewal at the Delivery Authority for the Palace of Westminster. Unfortunately, he's having some technical challenges due to what is going on at Parliament following the Queen's passing, so he's had to send his apologies for today's webinar, but we hope to get him speaking at a future webinar, so please do keep a lookout for those. And we've got lots of questions now, so I'll pass you over to Caroline, who's going to chair this section of the webinar.
That's great. Thank you, Amy. And Andy is due to speak at our next webinar on October the 13th, so hopefully we can have him then and he can fill us in with the project there. So lots of questions, which is great, but still please post some more questions if you have them. The first one is for Oliver, and it's just some clarification around the figures you used with the carbon reduction. And just ask, was that modelled or is that actually measured metered energy data that was used? You're on mute, Oliver.
I understand from the college it's metered energy data.
Wonderful, thank you. And just on that as well, is and actually there's been quite a few questions on this because I think it's a real exemplar approach in what you was able to do and what the college was happy for you to do and was able to put the funds available to all that investigation work, which a lot of us working in projects don't get that kind of opportunity to be able to do that.
No. Neither do we usually.
Well, that's what I was going to come to. People have said, and I know Amy, this was a question you also was interested in having the answer to. Do you find on the majority of projects, so for instance, the pressure testing, air pressure testing, that clients are just not willing to pay for that and just don't see the value in it?
I haven't found that on the air pressure testing because I mean, again, another question I spotted was about what were the principal kind of heat losses that we were facing, and one was windows, but the next one was infiltration. You know, there's a lot of very drafty historic buildings, and knowing how drafty they are is a really important point. And there are two forms of that. One is the gaps in stuff, you know, between windows and walls and doors and things. But the other is just it's vent extracts from kitchens and bathrooms and showers, where you're just chucking away expensively heated air. And being able to put a number on that was really important in persuading the client that actually this was something that was worth addressing. So usually when they understand that they don't know is the point at which spending a day and not very many thousands of pounds having a really good pressure door put in and going around with a thermal imaging camera, ideally in the winter, when certainly educational institutions are usually closed.
Yeah,
wasn't that disruptive. There was one member of staff who insisted on sitting in his room while all this was going on. He didn't come to any harm.
no.
But no, I think we underestimate the extent to which in historic buildings infiltration is a big problem. Is a big source of heat loss.
And for the scale, I mean, I don't know whether you'll be happy to share that, but for the scale of that building, could you give our listeners sort of an idea of what the cost of doing something like that would be as well, that type of investigation?
For an air pressure test, I'd have to dig out the figures and send them to you, but it wasn't
not as expensive as you'd think it would be.
No, I mean, it wasn't as expensive as some of the other monitoring and investigation we did. But again, it was a question of using the college. You know, I say they have a grade 1 listed estate with 1,500 students to house, and for them it was about finding out, developing a methodology, and finding out what were the important things to find out. You know, given that we were starting from a kind of ground zero, no one had any idea really, other than by using desktop models, which we soon discovered didn't really help. So you know, they've learned a lot, and it's certainly informed subsequent projects they've done, and other projects we've done. As I said earlier, with some of the things we did there, probably wouldn't do again.
Yeah.
And looking certainly at the kind of PSDS projects, saying, well, actually, what we're really going to do is sort out infiltration, the glazing, and heat pumps.
I think one of the other questions, because I mean, this being knowledge sharing, you've just said that the part of the university's driver for doing it is sharing that knowledge. I'm hoping that we'll be able to share a link to where we could find all that information as well, because I think that would be invaluable. There's some really good information there.
It's on. I can dig out a specific link, but it's in all of the investigation we did happened before we got listed building consent, because there was a certain amount of concern raised by your fellow officers at Historic England and by the Conservation Office and the City Council, and the college didn't want to do anything that was going to degrade their historic asset. So yeah, all that stuff is available in the technical appendices to the listed building consent on the Cambridge planning portal.
Okay, so we can find that there. That's great.
And I think, Julie, I've been talking about this for best part of 8 years. Certainly shared platforms with Julie discussing this in the past. Just even in the terms of pre-construction monitoring, actually, there's a whole load of stuff that you can do that makes the next step much less risky.
Absolutely. And actually on that, John, I've got a question for you. Someone's just posted there. Oh, I've just lost it actually. Let me just find that back there. Is a lot of the time, you mentioned about metering and metering data, particularly when you're sizing heating systems, and now we're moving on to using low and zero carbon systems, and how important it is to have that really good data. I don't know from my own experience, a lot of the time is getting that half-hourly data can be quite challenging. And I know you've mentioned that obviously that's the best data to have. Do you also retrospectively encourage your clients to put half-hourly metering, put in kind of systems where they can log that information? So, because as we know, if historic buildings, they're not just there for 25, maybe 30 years. They're going to be there. There's going to be lots more retrofit. So having that really good data, is that something you inform the clients as part of your projects?
Definitely, and particularly when we go for a kind of net zero carbon audit, and we look at the state of the data or what's available. It's often a strong recommendation off the back of that of, here are the steps we think you can take in the interventions, but really to refine this and quantify it better, you want to look at increasing your metering. And it is a constant challenge because some of it can be quite disruptive to install, particularly on the heat metering side. Electrical metering, I would say, is often easier to implement and therefore worth exploring as a minimum. Then really seeing what we can do on the heat metering. And like I said, you can start doing separate studies of clamp-on meters or temperature sensors within spaces to try and fill the gaps where that metering data is just not going to come.
Just on
definitely try and push for it.
That's great, John. Just on the back of that as well, someone's asked another question from what you presented. It said for 2% of the time when the heating load exceeds the heating capacity, do you find that clients will accept that possible reduced comfort levels if you've explained the benefits of having that slight reduction?
Yeah, I think that one can be quite a mixed bag, and this probably comes down to where we're talking across many sectors here. You've got some will be in the camp of, well, if it's only 1 or 2 degrees lower at those peak times, then people are barely going to notice it, and they'll be quite willing to take that. And this is where actually heritage buildings, people can be a bit more forgiving of the conditions. So if it's a little bit cooler than was originally designed for or what you were targeting, then it may arise in far fewer complaints than if you were in a new build, for example. So it's quite building specific, but you will get others then if they do want to have a plan B for what might happen. So whether there's even just some small boiler plant or something that gives them the comfort that they can get up to those peak outputs if necessary. But again, it's looking at what you size your main plant for, really.
Yeah, that's great. Thank you, John. Oliver, I've got one for you. Maybe something we sometimes don't always think about is, for your project, how well did the building meet the current acoustic requirements, and were there any modifications made? Was it a consideration?
Yes, it was. And when we lifted the old floorboards, We found some of the rooms still had some sort of sand pugging in the floor voids, but it had largely been removed when they'd installed the central heating.
Yeah.
So we put battens along each side of each joist and packed underneath them with mineral quilt, and then put a ply deck on and a bit more insulation, and then installed the underfloor heating within a screed, which was finished level to the top of the joists. And that not only gave us kind of good heat distribution, but that put some mass back into the floor. And by packing the other areas with insulation, we didn't have any kind of voids in the floor. And as far as I understand, I mean, people will always complain about someone playing the violin in the room above. But, I don't think that's really to do with the floors. It's probably, you know.
I suppose it's how well they play the violin as well, isn't it?
Yeah, exactly. But no, we were concerned about that, and we did do something about it.
Thank you, Oliver. There's actually another question on the fabric as well, and this is to do with the Portland cement. It says, was all the Portland cement removed and replaced with lime render to make the fabric breathable? I presume that was the case.
Yes, it was. Yeah.
And I mean, they're just making the comment they have a lot of cement rendered residential, and they have exactly the same issue. So obviously they can share from that. This is this other question is possibly one for CIBSE, and I don't know. I guess this is the purpose of this group. And Oliver, you touched on this about the use of lime and how those skills and those not having those skills, and it's how do we as CIBSE inform, upskill, broaden the skills base of the contractor market in order to be able to help with thermal performance of larger and older, hard to treat buildings in the UK? I don't think it's just CIBSE's responsibility, is it?
The country is in trouble then if there's only no. So what the main way that CIBSE do that, I mean, obviously there's specific training and guidance that we produce for the engineers, but when we're talking about the broader industry, the main way on retrofit that we have is by working with other bodies, and especially BSI, and promoting the PAS and associated guidance. It's also obviously indirectly promoted when you start, as CIBSE do, insisting on actual evaluation of outcomes, because this is generally where you find that there are skills gaps. But specifically on retrofit and people on site, etc., for CIBSE, the best is to work with others, including through the PAS working groups.
Yeah, thanks.
Yeah, there's an interesting point about lime, which conservation offices and historic England really like. I mean, it does have an appalling embodied carbon content. That said, we reckon that if we could use lime parging as our airtightness layer, and it has a fairly useful biocidal kind of qualities, so actually packing in lime around joist ends and in the pockets in brickwork where wall plates and things were, we felt that was quite a good use for it, and kind of it helped us excuse its enormous embodied carbon content.
We're closely sort of getting to 2 o'clock, but there is one question which I think is, I mean, both Oliver and John, you could both answer this one. They've asked me as well, but I'm not sure it's necessary Historic England to fund this, but particularly on your project, Oliver, there was a lot of time for that investigation work, which obviously cost a lot, and for people to factor that into projects. Is it something, John, you're probably able to answer this as well, when you look at historic buildings problems, and probably Amy as well, because you work on a lot of these projects, you know, convincing the client and saying you need to factor in a lot of time and more resource into that front end of the project, because you do need to do a lot of these investigations. You do need to understand how the fabric performs. I mean, just be maybe from each of you, just a quick sort of 30 seconds of how you sort of approach that.
Well, from our side, having spent a long time getting Newcourt right, it's made subsequent projects much faster. Yeah. You know, if you go in knowing that you need to do all the monitoring in the winter, and you've got a client that starts in January, you say, well, it's going to take a year before you get decent results from your in situ U value. So kind of it's enabled us to establish programs which can be much faster.
Yeah.
And certainly we're working on projects with listed buildings where the kind of that initial assessment stage has just taken a few months, and we've been in less than a year to listed building consent.
Wonderful. John?
Yeah, so I think from us, it's probably a fairly engineering approach of really being able to set out for them, well, here's the potential gains from finding this out here. If you can work out what your starting point is and where your greatest losses are, and in a lot of these cases, you can do some fairly simple calculations or refer to examples from previous projects that demonstrate the carbon or the cost savings that have been implemented as a result of finding that out and maximising the benefits as a result of it.
Yeah. And Amy, did you just want to, I think we've got time for Amy to finish because I know we're desperately running out of time.
I can do a quick 2 seconds. I mean, I think I
Thank you.
completely echo Oliver and John's points there. I would just, I guess, reaffirm the fact that for me, the difficulty historically has been demonstrating to clients and really convincing them it's worthwhile, the time, the money. But having more and more case studies coming to the fore like this in the public realm, it's going to be a far more compelling argument because we can demonstrate straight off case study, this is what can be achieved, these are your benefits, and it's just a far more compelling and easy argument to make.
Wonderful. I think that is all we have time for today. We've gone past 2 o'clock and we don't want to eat into any more of anyone's day. I hope everyone's enjoyed the session today. Our next one, and first, obviously, I'd like to thank Oliver and John for their contribution. Fantastic presentation, so thank you very much. Our next presentation, our next webinar is going to be October the 13th, same time, and I hope a lot of you can join us again. So I think I need to hand back to Julia at CIBSE.
Thank you very much, and thanks everyone again for joining the attendees, and thank you to all of our speakers today. As I mentioned, the recording will be available from tomorrow, and if you have any questions at all, please feel free to email me at jrennie, JRENNIE @cibse.org. All right, thanks everyone, take care.